Good evening, my name is Samantha, and I am a mathematics major at UNM. Today I would like to go over the algebra review from my first video about how to graph with using derivatives. So if you're looking for a little bit more of an extra algebra review, here it is. So first, when you're graphing a function, you want to start off with identifying your function. This means looking at the parent functions and identifying which parent function your equation was created from. This allows you to identify certain characteristics that you will need to look for. That way, your graph in the end will have the same behaviors. So today we are looking at a polynomial function, y equals x to the fourth minus 8x squared plus 8. And so because we're looking at a polynomial, we will want to find the degree of the function, the maximum number of turning points, the domain, end behavior and symmetry, and then especially for polynomials, we want to find our zeros and their multiplicities. So here are just some charts about how to graph polynomials, testing for symmetry, the effects of multiplicities, and then of course if you need a little reminder, what the domain is. So for our equation, we have a degree of 4, which you can find this from looking at the coefficient with the largest exponent. So that would be our first one here, which is x to the 4th. Usually, especially in textbooks, your equations should be in order, so usually it's the first one. But if not, it's just the one with the biggest number. And then your maximum turning points is just the degree of the polynomial minus 1. So this is just the maximum number of times your graph can turn, but it doesn't mean that it will turn that number. So for our graph, we have an end behavior that is going to look like this because we have a positive coefficient with an even exponent. If you need a little bit more details, here is a little chart about how the degree and the sign of the leading coefficient affect the end behaviors. So these points right here, these arrows represent what the end points on the graph should be doing. So for our graph, both of the end behaviors should be pointing up, like so. So to test symmetry, I just plugged in negative x for all the x values, and because I got back the exact same equation, that means it's going to be symmetric about the y-axis. This information is incredibly useful because it can make graphing really easy. The fact that I know that it is symmetric about the y-axis means I really only have to graph half the graph, because on the other side there should be a matching point. So for example, if I have negative 1, 1, I should also have a point 1, 1 on the other side. And for polynomials, our domain is all real numbers. Not always, but it's always good to double check. But for polynomials, it's usually all real numbers. And then over here, I have found our y-intercept, where you set x equal to 0, which is usually pretty easy. So this is the point that our graph will cross the y-axis. Sometimes you can have multiple points, but in this one we just have one. And then here we find the x-intercept, which is when you set y equal to 0. I would like to talk about this one a little bit because this one's a little bit tricky. The equation itself isn't factorable, so we're going to need to use the quadratic formula. Now, the quadratic formula is actually used for x squared. So here's the formula here, if you need a little reminder. And then, so I have went ahead and filled in all of my values, this coefficient being a, this coefficient being b, and this coefficient being c. And then once I got my answer here, as you can see, this is actually x squared. And because I'm actually looking at x to the 4th, I will need to take the square root of this number again. And that will actually, in fact, give me the x-intercepts. And remember that every time you take a square root, you actually have two numbers. You have a positive square root and a negative square root, which I should, in fact, have right here in front of this, because there are multiple possibilities. So here I have all 4 of the possibilities. As you can see, I have a negative and a positive, negative and a positive, but also on the inside, my signs are also switched, because on this sign here, we also had to do a plus or a minus. So that can be incredibly important, and it can really mess you up if you don't do the plus or minus, because then, you know, you might only get 2 points when there are actually 4. And this is kind of when the symmetry comes in handy, because if you know it's symmetric about the y-axis, then you know that you should have a matching negative and positive value. And for multiplicities, since all of them are only mentioned once, that means our graph is going to cross the x-axis in a linear way, which would look like this here, just straight through. So I hope this information helps you in graphing, and if you need help with using derivatives, go ahead and check out part 1 of my other video. Thanks!